So data visualizations can be really powerful. A good visualization will speak for itself. In other words, you can tell what it's talking about without even reading the text around it. That might help clarify some trends or interpretations. You should be able to stand alone. A good data visualization should be able to stand alone. Simple. It shouldn't be unnecessarily complex. There are really good complex visuals because they're telling a very complex story. But when possible, simplicity is always good. Shouldn't be a lot of text, so we want to focus on the visualization itself. And colors can be added in as a type of variable or type of information. So we should have something with colors. And to be honest, it's a lot easier to talk about good visualizations by looking at bad visualizations. So let's take a look at some bad visualizations. Um, Here is a case of minimum wages across time. You see two different visualizations of it here. My apologies, my picture is getting in the way there. Um, So the one on the left, it does have one big strength to it, and that is that it gives you the exact minimum wage for each year. Whereas the one on the right gives you dots for it, and it's much easier to see a trend here on the one on the right. That is one advantage. Now, when we talk about simplicity, these pictures here are just distracting, and they're not even accurate. If you would take this little dollar bill here, turn it sideways, and fit it into the one below it, you could probably put 3 or 4 copies of it. But this was $1.60, and this here is less than twice of this. So it's not proportional to the size, is not telling you about the minimum wage. So the pictures themselves are just completely distracting in this case. So this one is a nice clean one. I don't like that it's not labeled completely, but year is something that's pretty easy to figure out. And here the dollars is labeled. It's just upright. The y-axis is labeled. And it does start at 0, which is a good thing. That's not always the case, and that can be problematic. Okay, next thing. You know what? Maybe. Okay. Um, This one here is often done choosing a scale for your vertical axis. You want to be able to see all the data, um, but you want to be able to see the differences in the data too, the variation. So the one on the left makes it really hard to see the differences, say between quarter 1 and quarter 2, whereas the one on the right chooses an appropriate scaling. It's the same data. Both charts here are the same data, but this is a little easier to see how Q3 was so much more dominant other quarters. Okay, on this one, like I said, not having a 0, it's not necessarily a mistake, but you should have a good reason if you're not including 0 on your axis. And even if you're not going to scale the whole axis, maybe because then it would only be a tiny little thing and you couldn't see the changes if 0 was way down here. Notice how they do it on the right. So they're going by threes, every threes. If they went from 36 to 0, they'd have to have a really big space there, which would be kind of a space hog. So instead, they just give what's called an axis break. Why is that important? If you don't include 0 or show the reader that there's 0, there's the possibility of misleading them to see that changes that maybe aren't that drastic look really drastic. Maybe you see a big jump from here to here, a big dive. So it can distort the data a little bit if you don't at least include the 0 and let the user know that there's a 0. Okay, this one is something we've talked about already, but it's looked slightly different here. Let's say that you were graphing the number of A's received by students at some high school. You wanted to do some kind of gifted program or something. And you're looking at the first graph and you're saying, "Oh wow, the freshmen at this school are really sharp. They're really getting the A's." But the danger here is we may be comparing groups of different sizes. Um, And so because of that, like we've talked about, we really want to go towards a rate or a percentage so that we can compare them on an equal footing. So it could just be that the freshman class is absolutely huge. And yeah, of course they have more A's because they just have a lot more students. But here we see that 20% of the freshmen are getting A's, whereas 25% of the sophomores are getting A's. So the sophomores are actually doing better than the freshmen. Same data set for both of these, even though the freshmen are getting a higher number of A's. This percentage or the rate is much better for comparing groups of different sizes. Here we have one big issue. It is a nice pie graph. It's attractive. The colors are great. But if you add up the percentages, right here, 30 and 70, you already have 100, and then you have 51 more. So 150%. A pie graph should add up to 100% or very close, 99, 101% because of maybe some rounding error, but certainly not 151%. So what's going on here is you can see the error up here. The data are being recorded into multiple slices. These new businesses that survive 10 years are also part of the category that survives 5 and the category that survives 2. When you do a pie chart, every data point should fit into one and only one slice. That's really important. That's what makes everything add up to 100%. So here, it's clearly not working. This pie chart actually looks pretty attractive. This was a scouting report looking at this picture, different types of pitches. One of the problems here is you don't want to use 3D graphs, especially pie charts and bar charts, because look at what happens. When you use a 3D graph, this little edge right here um, makes it look like it's extra part of the area of the 11%, whereas the 60% here, that entire back edge isn't exposed to us. So this is distorting the data to make whatever data is up at the front of the chart look like it's bigger than it really is. So that's a problem there. Another problem, I'm not seeing it here with the pie charts. Actually, let's take a look at this pie chart. Yeah, that's a lot of categories. Pie charts really are best suited for maybe 3 to 7 categories. This is way too many. This is out of control. Looks kind of cool, I guess. If you wanted some kind of story here, the one maybe redemptive part of this is most active tweeters, is just to show like download 11, how massive their Twittersphere, sorry, I'm not sure, but their impact, Twitter impact is relative to the other big users. Actually, the top 2 or 3 have almost a quarter of the tweets here. So that would be maybe one message. But in general, this is not, I mean, you're recycling colors. You can't even tell which user is which in the pie chart. In general, this is what I was going to say. Pie charts are not good for telling little differences between categories. This has 27%, this has 26%, like maybe happening here, something of very close amounts. Pie charts make it hard to tell the difference between them. Whereas a bar chart, if they're right next to each other, you can see which bar is taller. So it's better for telling little differences between them. Okay, so bar chart here, couple things wrong. Again, we have the 3D aspect, which puts extra distortion on the top categories and less on these middle categories. So better to have a 2D bar chart. It also doesn't have a title or labels, so it's not very self-explanatory. You would need extra text to explain what's going on here. And finally, similar thing here, we don't have the x-axis labeled, although here we can tell it states. It's still better to have a label whenever possible. There's a misspelling, so whenever you make a data visualization, because there aren't very many words, when you have misspellings, there's really attention drawn to it that you don't want. So you want to double check your spelling on any visualizations. And the biggest statistical issue with this one is, like we've talked about, if you have categorical data on the x-axis, like we do here, you should not have a line graph. You should not have time series. You should not have line graphs. You should not have a histogram. These are only for quantitative data here, because it makes it look like there's some kind of trend with a hump in the middle, but it's really arbitrary, the order that we put categories in. We could start with Illinois, then Missouri, then Indiana, Michigan, and Illinois, and it would look like there's some kind of upward trend, which is completely wrong. Or we could flip them all and make it look like a downward trend. There's really no trends going on here at all in terms of from state to state, the category. So categorical data on here, you should not use a line graph. So those are some of the biggest mistakes to visualizations.